What is up, you guys?
This is awesome. This is amazing. I mean, come on. Don't tell me you don't like that. NVIDIA Volta V100, NVIDIA Turing T4, and NVIDIA A100 GPU. I'm using NVIDIA's Titan RTX, and thus it's powered by a Turing architecture, so I'm good to go. Okay. The article name, so article, and we're going to have a summary. What is up, you guys? In this one, I'm going to show you all the basics, everything you need to know to get started with the awesome Jarvis framework provided to us for free. It's open source by NVIDIA. It was recently released on the 25th of February 2021. Now, to fully leverage Jarvis, we're going to be using Python. And we're going to see how to perform automatic speech recognition, speech synthesis, natural language processing, and by the end of the video, I'm going to show you a small demo which involves a question answering application using this wonderful Jarvis package. So in other words, we're going to type a question in and see how Jarvis is going to respond. I hope you're excited as I am. So without further ado, let's get started. So what is Jarvis? It's an application framework for building multimodal conversational AI services that use an end-to-end deep learning pipeline. This is the definition provided to us by NVIDIA. Now, the Jarvis framework consists of pre-trained conversational AI models and optimized end-to-end services to speech, vision, and natural language understanding tasks. Now, the Jarvis framework includes pre-trained conversational AI models such as those in speech recognition, speech synthesis, and natural language understanding. Now, Jarvis includes a rich database of pre-trained conversational AI models trained with over 7,000 hours of speech data using acoustical models such as Jasper, which basically runs in PyTorch to achieve high accuracy and outstanding performance using NVIDIA's Tensor RT. Now, also for automatic speech recognition, NVIDIA provides us with QuartzNet. Now, QuartzNet is similar to Jasper. However, the good thing about QuartzNet is that it has much few parameters to train compared to Jasper. Also for NLP, NVIDIA uses or relies on BERT, which stands for Bidirectional Encoder Representations from Transformers, which was created and published in 2018 by Jacob Devlin and his team at Google. BERT is a transformer-based machine learning technique for NLP pre-training purposes. Now, as you can see over here, we've got a workflow provided to us by NVIDIA that is referred to as TLT, or Transfer Learning Toolkit, which allows us to train models with almost a zero coding approach. And this is of high interest basically for enterprises that do not have a coding background. So all you need to do is use NVIDIA's rich training data, plus you could also use your own custom training data on top of the existing one provided by the NGC, NVIDIA's GPU cloud, to fully leverage Jarvis services and to achieve high training performances. So before we get started, make sure you're running on a Linux x86 64. That is a 64-bit version of x86 instruction set, but on a Linux machine like Ubuntu, CentOS, Fedora, Linux Mint, Manjaro, Arch Linux, Kali Linux, or any distribution running Linux. Also, make sure that you're running on an appropriate GPU, such as NVIDIA Volta V100, NVIDIA Turing T4, and NVIDIA A100 GPU. I'm using NVIDIA's Titan RTX, and thus it's powered by a Turing architecture, so I'm good to go. Okay, so the first thing you'd want to do is open a terminal and install Docker. Now, Docker is formed of packages called containers, and it's a type of service that offers OS level virtualization. So it makes it much easier for developers to deploy their apps on servers. And it's really fast because all the containers within the server operate using a single OS kernel. So they're all sharing resources when these resources are available. Now, unlike other platforms, Docker tries to make use of many resources and thus requires less computation and less time to perform requests. So to install Docker, all you need to do is open your terminal and type in sudo apt-get update first of all. Enter your password, if any. Now, since I have it, it's not going to take a lot of time, so we're going to install. So sudo apt-get install docker-ce, docker-ce-cli, and last but not least, containerd.io. Again, since I have it, this doesn't take much time. Last but not least, to make sure that you have Docker on your machine, just run sudo docker run hello world. And there you have it, hello from Docker. So this ensures that you have Docker installed on your machine. Next, what we'd want to install is CUDA. Now, CUDA is a very popular platform developed and provided by NVIDIA. It enables parallel computing on GPUs. Now, you have to also have the driver. So run NVIDIA-SMI. I'm running on a Titan RTX. So you should have one of the following three. Now, back to CUDA. CUDA is a very powerful platform that is designed to work with low-level programming languages such as C, C++, and Fortran. It makes it easy for programmers and for people working in parallel computing to efficiently use GPU resource. Now, to install CUDA, just run a sudo apt update and then a sudo apt install NVIDIA CUDA toolkit. This ensures the installation. Now, since I have it, it's telling me that the NVIDIA CUDA toolkit is already the newest version, 10.1. So at this point, I've got Docker, I've got CUDA. Now we need to install Jarvis. So make a directory for this. Let's call it Jarvis folder and cd into that. Now, to install Jarvis, we need access to NVIDIA's GPU cloud. So first of all, what is NGC? It's a GPU accelerated cloud platform that is dedicated for scientific computing, AI, applications, machine and deep learning, and related areas. Now, NGC is responsible of managing highly optimized deep learning framework containers that take full advantage of NVIDIA GPUs. As you can see over here, we've got all those collections. Go over here to containers. You've got NVIDIA Kubernetes device plugin, you've got CUDA samples, DeepStream, Jarvis speech skill, which we're going to talk about today, NVIDIA GPU operators, and many, many more. Now, to install NGC, you need to create an account here. I'll be leaving the link to NGC in the description section below. After you create your account, you go on to Setup, Downloads, and you've got a step-by-step configuration and installation of NGC. Now, since I'm running on a Linux operating system, I'm going to copy paste each and every one. So go here, this is NGC. Now let's check the binaries MD5 hash. Ensure they're not corrupted. Okay, means they're good. Add the current directory path. There you go. Configure NGC. Okay, so here NGC is asking us for a API key. Right here, we've got the generate API key. There you go. And right here, you click generate API key. Since I have it, I'm not going to click on confirm. I have it saved right here. I'm going to copy paste it right here. Now then, NGC prompts us to enter an output format type. We've got ASCII, CSV, and JSON. I'll just go for CSV. All the configurations are found in this path right here. And now I'm ready to install Jarvis. So now clear. Go ahead and type NGC registry resource download version NVIDIA/Jarvis _ quick start version 1.0.0 B.1. Okay, so this is done. ls. There you go. So we've got the folder Jarvis _ quick start _ the version and beta mode. So we'll cd into that. And there you go. We've got all the bash files needed to start Jarvis on our machine. The first thing you'd want to do is initialize Jarvis. Now that's where it's going to take some time to download, and this highly depends on your internet speed. So bash jarvis underscore init.sh, permission denied, so we'll run it in sudo mode. And here it's asking me again for my API key. So I'll paste my key. Now, since I have it, it's not going to take a lot of time. But if you don't have it, just leave it some time to download from the internet. And don't worry. So here it's warning me I already have, for example, Jarvis, text classification domain, and so on. So for me, this should finish any time now. Now that the initialization phase is done, it's telling us to run the bash file jarvis underscore start. So sudo bash jarvis underscore start.sh. And here it's where it's going to connect to a Jarvis server. So as you can see, the start bash file is waiting for the Jarvis server to load all models. So leave it some time. It's trying to find a Jarvis server to connect to. So now Jarvis server is ready. Now we're connected to a Jarvis server. The last bash command that we're going to run, the last bash file that we're going to execute, is the Jarvis start client. So now, as you can see, we're running in another kernel. So now I can clear everything and open my Jupyter notebook. So Jupyter notebook, and it's telling me to use allow root to bypass. So we'll pass it this flag, and it gives me 3 links that I can use on my browser. So let me put this guy over here, this guy over here, this guy over here. I don't need this. I don't need this. I don't need this. Paste this link over here. I'll create a new Jupyter notebook. Call it Hello Jarvis. So I'm on my Jupyter notebook, which is running on Google Chrome. So the first thing you'd want to do is connect to the Jarvis Speech API server. To do that, we're going to have to create Jarvis clients so that we could connect them to the appropriate servers via certain ports. What you'd want to do first of all is import the gRPC Python module. So gRPC is an open source remote procedure call, and it's a way to, to connect with the server via HTTP2 for transport protocol, buffers, and these good stuff. It uses a lot of authentication via TLS, which is the transport layer security system. So that's how sockets, communicate with each other. It also uses encoding for protocol buffers to encode data. So this is gRPC, but we'll only be using it to create a channel, and to be more precise, using the insecure channel. Over here, you define if you're working on a local host, you go ahead and specify the port. So right now, I'll just specify 551 as such. And by the way, in case server deployment is on a different host, or in case, you're using Kubernetes, you should specify the, your appropriate URI. Right now, I'm working on a local host, so this should do. So there you go. I have my channel. And so right now we're going to have to connect to Jarvis servers. So let me get rid of this. I'm going to import Jarvis underscore API dot Jarvis underscore ASR for automatic speech recognition applications. I'll give it an alias, let's say JASR, Jarvis is ASR underscore server, because we're going to be connecting to that guy. And to do that, well, we go server.jarvis ASR stub, and we pass it the channel. And there you go. So this is how you create your own client. And this, I'm going to store it in Jarvis underscore ASR as such. Okay? So this is for the Jarvis automatic speech recognition server. Now to get full functionality, we're going to import the functions. So this guy, without the gRPC, simply as JASR, Jarvis's automatic speech recognition. So now we're connected to the server, and we can do some cool stuff with the automatic speech recognition with Jarvis's speech API. So this guy handles ASR. Now, like ASR, Jarvis also, let me organize stuff over here. This is for automatic speech recognition. Now let's connect to Jarvis's natural language processing API. And as we did previously, we're going to import Jarvis underscore API dot Jarvis underscore NLP underscore PB2 underscore gRPC as JNLP underscore server, right? And for full functionality, we're going to import as well the same guy without the gRPC, right? And we'll give it another alias, let's say JNLP for short. So the NLP provides all functionalities that have to do with, understanding the context of text, whether you're talking about weather or food or money. This API is capable of understanding what you're talking about, and we'll see how. Now, like NLP, there's the CNLP, which stands for Core NLP, or Core Natural Language Processing. And the modules that are related to NLP, like JNLP, we're going to add C's everywhere before the N, as simple as that, and specify NLP core as such. I'm going to remove this channel from here because it is inappropriate. It's well suited on the second cell. So running this API, not APO. I did a typo. It's not Jarvis, it's Jarvis. And there you go. And last but not least, we're going to provide the Jarvis API TTS related, that is text to speech. And for that, we're going to import Jarvis underscore API dot Jarvis underscore TTS underscore PB2 as, let's give it an alias, so Jarvis TTS. Okay. Likewise, for the server, it goes with a gRPC as such. And we'll give it an alias, let's say JTTS underscore SRV as such. And last but not least, for some audio functionality, we're going to import the audio underscore PB2 from Jarvis's API as JA. Simple as that. Now we've got 1, 2, 3, 4 servers that we have to connect to. We connected to one, that is the ASR server. Now we have 3 more to connect to. So I'm going to copy paste this 3 times. And for the NLP, we should indicate that we're using JNLP underscore server dot Jarvis NLP stub and call the client Jarvis NLP. Likewise, for the JC NLP, we'll call it Jarvis CNLP. And right here, this guy is Jarvis Core NLP. And last but not least, for the TTS, text-to-speech server, we'll specify Jarvis underscore TTS. And over here, JTTS underscore server dot Jarvis TTS stub. And there you go. This is how you connect to the 4 servers. Now we're ready to dive deeper into the fruitful and useful functionality of Jarvis. First, let's talk about automatic speech recognition. So right here, I'm going to open a cell, call it ASR. And for ASR, what we're going to start doing is that I'm going to read a certain audio file in my path. So it is in the following path. I'm going to specify the complete path. And I'm going to use Librosa. So Librosa, we should import it first of all. So import Librosa. Librosa is a Python package related to music audio processing. So it makes it much easier, to handle different audio files so that you can efficiently work with them in Python. So we're going to call librosa.core.load, specify the path, and we're going to return the audio file. Let's run this. There you go. We have our audio samples right here. And a really nice way to, verify the content of your audio, we can use IPython, and in particular the display submodule of IPython. IPython is a Python module which contains a lot of functionalities that have to do with interactive computing. So in case you've got a lot of figures, graphical user interface, audio, speech, then this package will be very, very useful to you. And I'll show you what I'll be using exactly. I'll be using the IPD, which gives me a nice GUI, a graphical user interface, to play my audio clip. So let's import IO as well, which is a Python package that has to do with input output file related operations. So the way you read your audio goes like this. You open the path that you specified. Let's give it an alias F. Your content, you should read your content as such. And last but not least, your audio will be presented as such. So if I go ahead and play it, this is my sample that says,
what is natural language processing?
Okay, now what ASR is going to help us do is recognize what has been said here.
What is natural language processing?
So it should be able to tell me that, okay, this audio clip contains the content.
What is natural language processing?
So let's see how this could be done on Jarvis's ASR. It's very easy. This package is meant for, people that are into one-line coding. You know what I mean? So if you're writing some prototype and you want an application based on automatic speech recognition, then I highly recommend this submodule of the big Jarvis. Okay, so the first thing we'd want to do is set up an offline recognition request. And the way to do that is call JASR, which is over here, the recognize request. So we're defining a request over here. You could see this as a structure that has, as we will see, we're going to configure this structure. We're going to pass it several parameters related to this audio speech signal. And all these information have to do with speech. So for example, I can go ahead and say request.audio is the content, which I read it using Python's input output package, the IO package. I'll pass it the content of the audio file. Next, so the content right here is encoded using UTF-8. So UTF-8 is one type of encoding. Go ahead and read about it. UTF-8 stands for Unicode Transformation Format. As you can see, it's a way to encode your, in our case, audio signal in a compact type of way. And here's the signal. So this is what we're going to pass to Jarvis right here using the audio field of the request. Next, let's define, so let's open config. So we're going to configure, we're going to have to tell the Jarvis server, we're going to have to tell it the sampling rate of the signal. And how do we get that? Well, Librosa is very useful to an extent that it also provides us not only with the audio signal, but also with the sampling rate. So if I go ahead and run this, if I go ahead down here and let's create a new cell. So cell, where is this thing? Maybe it's a plus. Yeah, there you go. Sample rate, it's 22,050 Hertz. Okay, so here it's in Hertz, so I'm good. If it's in kilohertz, I need to multiply by 10 power 3. If it's in megahertz, 10 power 6, but there's no audio signal that is in megahertz. So it's usually between 20 and 22,000, 23,000. And as we get older, this interval shrinks down. So the 20 is increased, and the 22,000 is decreased. It's as if the bandwidth of your ears, which act as filters, or to be more specific, as bandpass filters, the bandwidth of your ears shrinks with time. Anyways, so we'll have to pass it the sampling rate. We're also going to have to pass it the language code. So in our case, it's English USA, okay? For the moment, since my audio wave is in English, we're going to have to tell the Jarvis server, the Jarvis ASR server, that the person talking in this audio is using English language. Next off, we can also configure a very, very nice feature over here that is the alternatives. And this actually provides you with alternate text. So let's say that the audio said, I don't know, give me a certain homophone. So let's say the audio says right. So right. So this right. not right as such. Jarvis is able to return both. But in our case, let's set it to 1 because over here the text is actually, the audio signal is actually clear.
What is natural language processing?
Okay. You can also tell the Jarvis ASR server to enable automatic punctuation and set this to true. So if it's a question, end the phrase with a question mark, start the phrase with an uppercase. The first letter of the first word in the phrase should be uppercase. If there's commas, there's full stops, if the person pauses, Jarvis is able to digest all this and respond by meaningful text strings that is well punctuated. So we're going to set this to true, and we're also going to configure the channel count, which is set to 1. Last but not least, we're going to configure the audio encoding. This is encoding, and right here we're going to use JAW, which is the Jarvis API audio, and tell it that we will be interested in linear PCM, which is linear pulse code modulation, commonly known and used in signal processing and audio processing. We've got also other audio encodings such as, allow, which is a different type of encoding. You've also got free lossless audio codec or FLAC, and you've also got the mu law as well. Okay, I think we're good to go. We could create our request. This is the request that we're going to send to the Jarvis ASR server. And we're going to need a response. The Jarvis server is going to respond and return it in response. But how are we going to create this response? Well, we're going to call the Jarvis ASR server right here to recognize our request as such. So over here is the response. We can go ahead and check it. Here's the results. So the results, you've got alternatives, 1 alternative. You've got where we define it over here, max alternatives, we set it to 1. Let's say we set it to 2. Well, it just gave us 1 because it's so confident, because Jarvis ASR was so confident that the audio contains the following transcript. What is natural language processing? And since we enabled punctuation, then it ended the sentence with a question mark and it started it with a capital letter. Let's say I set the punctuation to false, and there you go. No question mark, no uppercase. So setting this to true. So we can go ahead and extract this response and useful text. So the way to extract the transcript is easily done through response.results. So since we have 1 result, then the first one, 0.results. This is I think the response is in JSON. So the way to access this is very easy. Alternatives is nested inside results. So you go results.alternatives. You've got only 1 alternative. Then you access the transcript as such. So this is my first Jarvis transcript. There you go. And you can go ahead and print it as such. Content or transcript is my first Jarvis transcript, and there you go. So this is a really small application, very useful, very easy, very compact. As you can see, all you have to do is just define the path of your audio signal, .wave for example. You've got your transcript thanks to Jarvis's ASR server. Okay, so now let's play around with the core NLP API by Jarvis, and we're going to start with the punctuation model. That is, given a sentence that is, or a phrase, not necessarily a sentence. So let's say my phrase is, something like, I am in love with the Titan RTX by NVIDIA. As such, let's see how we can punctuate this phrase. So I might as well call it phrase. And the first thing we'd want to do is, as we did with the JASR, we configured a certain request before sending it to the Jarvis ASR server. We're going to do the same thing here, but configure it slightly different. So we're going to call JCNLP, that is this guy right here, that has to do with the CNLP. And in particular, we're going to call the function text transform request. So this is our request that we will be sending after configuring. So what we're going to configure is the name of the model. We're going to name it Jarvis underscore punctuation as such. Next, we're going to pass it the phrase, obviously using append, because here we can append multiple phrases. I'll show you how. It's really easy. And last but not least, we're going to get our response using the Jarvis CNLP server by calling transform text and passing the request. Running this, checking the response, and there you have it. We have our sentence punctuated, right? I am in love with the Titan RTX by NVIDIA. Okay, well, let's say someone threw in another phrase within this phrase. So let's say I just said I am in love with the Titan RTX by NVIDIA, and suddenly I just said, I don't know, it is hot outside. I don't know, just randomly I just said that. Well, let's send this request and see what the response is. And there you go. So it's not that we naively added a full stop at the end of the sentence. No, the punctuation model, and to be more precise, the transform text function was smart to handle, different text. That's because there's a lot of natural language processing running beneath the hood. And so this function was capable of, figuring out that this is one sentence, whereas this is another sentence. Well, let's say we added a question like, how are you today? As such, run it, and there you go. It was also capable of figuring out that how are you today is a sentence. And not only that, it's a question. So let's say you have another phrase coming in, right? So let's say I've got phrase 2. Let's call this phrase 1, pass it here. Let's say, I don't know, it's cloudy in Nice, France. Run. Well, nothing happened because I didn't tell the request that I've got a phrase 2 that is coming in. Well, you have to append it. Request.text.append phrase 2. And there you go. It's cloudy in Nice, France. Well, that's dumb because the point of this is to show you that this punctuates by itself. So I'm going to do this, and there you go. It has been punctuated. Let's add in a third phrase saying Byblos. Okay, so Byblos is a city, and I'm going to do this. So Byblos lies in the north of Lebanon. As such, appending the phrase, running, and there you go. Byblos, uppercase, Lebanon is also uppercase. So the transform text was also able to realize that Lebanon is a country, and so it is uppercase. Last but not least, I'm going to add another phrase. Let's say, did I mention that I am in love with those Titan RTX GPUs? Appending, and there you go. Did I mention that I am in love with those Titan RTX GPUs? Let's add in the last sentence. I'm having fun here. So, by the way, did you see the A100 PCIe 40 gigs HBM2 graphic cards by NVIDIA? Appending, sending the request, and there you have the response. By the way, comma. So you've got a comma right here. You've got a comma right here. Did you see the A100 PCIe 40 gigabyte HBM2 graphic cards by NVIDIA? Now that's pretty cool. So this function is really handy to use when you've got unpunctuated phrases coming in and you want to figure out different sentences, questions, punctuation, commas, quotations, and all these good stuff. Now we're going to take a look at another awesome API, that is the token classification API. It's a bit freaky and it's one of my favorites because it is capable of dissecting the sentences into, entities where each entity has its own context and its own meaning. Let me show you what I mean. So let's say you've got a sentence or a phrase as we did previously. So phrase 1, Siva DSP is a company headquartered in Rockville, Maryland. Okay, so as we did previously, we're going to instantiate a request. We're going to ask the Jarvis core NLP server, we're going to ask using the token class request. Okay, and we're going to specify the model. That is, I'm going to use the Jarvis NER model for training, and we're going to append the text that we have as such. And finally, we're going to get our response using the Jarvis CNLP server, and in particular using the classify tokens function. Finally, I'm going to print the response. And there you have it. So Siva DSP is an organization with 0.99 score, that is 99% confidence. And Rockville, Maryland is a location with 99.6% confidence. So not only is it capable of classifying tokens, but also it tells you how confident it is using this score metric. So let's say the Jarvis CNLP training model wasn't that sure, it wouldn't give you a 99% confidence. It would give you a much less metric, which is really good. It's giving you a soft decision over here, telling you, oh, here's what I'm classifying, and it's labeling each class using the score. Labeling not as not as classifying. I mean, it's attaching to each class a certain probability. Okay, let's put it that way. Okay, so that's it for token classification. Last thing I would like to talk about in the core NLP API of Jarvis is text classification. So text classification, which is a bit different from token classification, will take a phrase and classify it into its relevant context. So let's say I'm asking, what is your favorite football player? And I ask this question. So to get the classification, we're going to use jcnlp.text class request as such. And by the way, you can also deploy your custom model. So if you've got training data that you would like to add on top of the existing one provided by Jarvis, you can go ahead and do that. For the moment, I don't have training data, so I'm not going to, supply it. I'm just going to use the training data provided by Jarvis, which in this case is Jarvis underscore text classification domain. And as we did previously, we're going to append the phrase and get the response through the appropriate server, which in our case is Jarvis underscore CNLP, through the classified text, pass it the request, and get the response. And there you go. Oh, and by the way, currently Jarvis uses over here 4 classes. And this is referred to as the Misty. So Misty is a fictitious character. I don't know if you've seen the YouTube video by the CEO of NVIDIA, Jensen Huang. He actually did a pretty cool demo. He was talking real time with Misty. So Misty is a fictitious character running Jarvis in its backend. So Misty right here has 4 classes. One is personality, obviously, and one is about weather, one is about meteorology, and the last one I think is no class, something like that, so, or no match. So let's say, for instance, I go ahead and say, what is the main reason behind raining? Well, let's see. I think this lies between personality and weather, because personality, this actually implies that this is a curious person. What is the main reason behind raining? I mean, you don't usually get a question like this, right? And this over here is meteorology. So let's see what Misty has to say. So let's add it on top of phrase 1. Oh, it's meteorology. Right, because I'm asking about rain. Okay. Okay. Let's add one thing about, let's add another phrase. I don't know, phrase 3. Is it sunny in Nice? Let's add it over here. And there you go. Weather, 99.75% of confidence. Okay, good. So this is how the text classification works. So in this Jarvis API, the CNLP, we talked about for 3 models that are the punctuation, token classification, and text classification. Now let's go ahead, take this a step further. So one amazing topic I'd like to talk about is the text-to-speech API service by Jarvis. This is one really interesting and characteristic feature of Jarvis. And actually, for those of you who don't know, synthesis is the inverse operation of speech recognition, which is given a string of text, transform this string into human-like speech. Not any robot sounding speech, no, human-like. And I would like to emphasize on the word human-like because that's what I think Jarvis did a pretty good job. This feature is also very characteristic of NVIDIA's Jarvis. So let me show you what I mean. Let's open a request, first of all, call it synthesize speech request, okay? And in this request, I'm going to pass a string. And let's say, what is up, you guys? So this is my intro of the channel. Okay. And we're going to pass it also the language code, which in my case is English US. Let's pass it the sampling rate in Hertz. Let's fix this to 22,050 Hertz. Let's pass it the encoding. So as we did previously in ASR, we can pass it let's say linear PCM, okay? Let's get the response through the Jarvis text-to-speech server, and in particular, synthesize. Get the request. I'm sorry, this is JA, not JS. Okay, we got the response. Let's see how it looks like. So it's encoding. There's this encoded string, and now let's transform it to something useful, that is audible speech. So for that, I'm going to use NumPy. So import NumPy as NP. And we're going to get the audio samples from buffer, pass it the audio, and tell it that my type is in 32-bit floating representation. Last but not least, I'm going to use IPython's display functionality and the audio in particular to transform the audio samples at rate 22,050 Hertz. So I've got an error over here, and the error should come from here. So this is response. There you go.
What is up, you guys?
This is awesome. This is amazing. I mean, come on. Don't tell me you don't like that. I mean, I love it.
What is up, you guys? What is up, you guys?
Sounds really, really, really real, right? Well, let's state some fact. I don't know. Convex optimization is really fun. Stay tuned for more lectures. Okay. Let's run this.
Convex optimization is really fun. Stay tuned for more lectures.
This is amazing. I just love it. I love it. I love it. And I love what NVIDIA did over here. And thank you, NVIDIA, for providing this useful API. Actually, I'm going to be using this for some of my videos. Again, thank you, NVIDIA. So let's go to the NLP API by Jarvis. Now we can also analyze intentions using Jarvis's NLP API. Let me show you how. So first open a request using JNLP's analyze intent request. Pass it the, let's say we're going to talk about the weather. So we'll pass it the domain, that is weather, and we're going to specify the phrase. So let's say I've got phrase 1, that is it currently cloudy in China? In the query, we'll pass it the phrase, and then we'll get our response using Jarvis NLP server, and in particular through the analyze intent. Pass it the request. There you go. We have our response, that is weather.cloudy. Because I mentioned cloudy and it is 97.5% sure. Weather place China 92.5 because that's the place of the weather I'm concerned in, China. And weather place, there's nothing right here, 65, so you can forget about that. And yeah, this is how you could analyze intents. So it's the maximum of the scores. You get the class name, the maximum. Okay, so let me show you how this is useful. I'm going to print out the response.intent. So response intent class name. Let's put some tabulation over here and phrase 1. And there you go. Weather, cloudy. We're talking about cloudy weather in China. Well, let's pass in another phrase. I don't know. What is the annual rainfall in Pune? Let's open another request for that. Actually, let's do a for loop over here. We can store all those guys in an array called phrases as so. So right here. Okay. And so for phrase and phrases, do some indentation over here. So this guy becomes a phrase. You get the response and we print it along with the phrase. There you go. The context, the intent is rainfall. Let's add one more sentence. How about the humidity in San Francisco? So humidity is the intent. And I don't know if you've noticed, but the speed of, talking to the server, to the Jarvis server, and the request and the response is high. So low latency between the endpoint and the server. And that's really characteristic of Jarvis. Let me show you what I mean. So I'm going to measure the time to complete requests. So let's say I'm going to open a request. Let's say for no reason, the JC NLP text transform request. And I'm going to send the following. GPUs give you superpowers, and not any GPUs, but NVIDIA GPUs in particular. Okay, so this is my text that I'm going to be sending. To measure time in Python, you're going to need the time submodule of the module or package time. Okay, so let's define a starting time. So get the current time and let's iterate over, let's say 10 iterations and get the response each time using the Jarvis NLP server. We will pass it the punctuate. We will call punctuate text, pass it the request, run this 10 times, and then measure the time at the end. And we're going to print out the total time needed to complete, say a number of iterations right here. So over here, we're running synchronous requests, right? And the way to measure it is this guy minus this guy. So end time minus start time. So run this and I have an error, and my error is over here. So I should end it right here. So it actually took me 0.09 seconds to run all this. It's pretty awesome. That's pretty fast. You can also measure the time taken to perform asynchronous requests. So first, starting time. Let's define an array of futures and let's run 10 iterations. Each time we will append Jarvis underscore NLP dot, let's say, punctuate text as before. But this time, we'll pass it the futures. We're measuring asynchronous request times. And then in the future, this is similar to C++. We will get the result. So I don't want it now, I want it in the future. That's how you should read it. Okay, so at the end of the day, we'll measure the time. And then I'll copy paste this guy right here. Change this to asynchronous. And I think that this is it. And there you go. 0.07 seconds. That's really fast. Okay, so this is all the basics, really. This is all you need to know to get started with Jarvis's NVIDIA's API. Now I'm going to show you a really cool demo right here that we're going to call question/answering Jarvis app. And Jarvis right here is going to make use of Wikipedia. So question answering Jarvis app, Wikipedia based. So what we're going to do here is make use of all Wikipedia, public Wikipedia articles. Based on this information, we're going to try to answer some questions. And for that, we're going to install Wikipedia. So for those of you who don't know, Wikipedia is actually, Python has a module called Wikipedia that goes to the web and reads Wikipedia articles, right? Okay, so we're going to import Wikipedia as wiki, okay? Now, of course, we're not going to load all the Wikipedia articles there is, because this is going to be very time consuming and impossible to load on one machine. Instead, we're going to take the question, let's say, what is speech recognition, right? And we're going to search Wikipedia articles based on this input. We'll return it inside articles as such. We're going to accept a maximum number of combined articles. So if there's more than a certain threshold, I don't want it. I want the first, let's say, 3 articles. Okay, so now let's loop into all 3 articles. So for article in articles, as we said, we want only 3 of those. So the min between that and the maximum number of combined articles as such. Okay, and let's print the article name. So article, and we're going to have a summary. So each time I'm going to append, of course with a \n each time, the summary of the article. Wikipedia also provides you with a function called summary to get the summary of the article. So the first paragraph appearing in the Wikipedia article, I'll show you just now. And we're going to initialize summary as empty. Last but not least, I'll print the summary. Oh, I've got a, okay, so this is the summary, summary 1, summary 2, and summary 3. I did a mistake right here. Should start with an F. There you go. This is the title of the first article, speech recognition, right here. This is the title of the second Wikipedia article, right here. And this is the title of the third Wikipedia article right here. So if you go to the web and type in speech recognition, let's see. Let me just add one keyword, that is Wikipedia. So speech recognition right here is an interdisciplinary subfield of computer science. Let's go back here. There you go. This is found right here. This is the same as this. Let's go back, see if there's other articles. There's, well, actually we can know them by the title. Windows speech recognition. Windows speech recognition, it's over here. Is a speech recognition developed by Microsoft for Windows Vista. Okay, there you go. This is the summary. Okay, and now we're going to make use of the Jarvis NLP server. And in particular, this server right here. So let me get it. And we're going to get the response from the Jarvis _NLP using natural query. Pass it the request, and before we need to configure the request. So for that, I'm going to use jnlp.natural query request, and now we will configure it. So of course we need to pass it the query, that is the input right here, and we're going to pass it the context that we read from Wikipedia, that is the summary right here, which is all this. Okay, and there you go. So running this is the response. Here's the answer. An interdisciplinary subfield of computer science and computational linguistics that develops methodologies and technologies that enable the recognition and translation of spoken language into text of computers. You can format it since we're building an app right here. So the query that started all this was the input, and the answer is the response dot results, right? And since it is possible to have multiple results, we're going to pick the first one just for convenience right here and pick the answer. And there you go. You can go ahead and play with this by passing different questions. So let's say, what is computer science? There you go. Let's see what Jarvis has to say. It is the study of algorithmic processes, computational machines, and computation itself. Let's ask it, what is quantum mechanics? Go Jarvis. Okay, there you go. An attempt to explain how the mathematical theory of quantum mechanics corresponds to reality. Very philosophical. Jarvis is not only intelligent, but also philosophical. Okay, so I hope you had fun as much as I did. This is a really rich and fruitful package given to us for free by NVIDIA. There you go, it's open source. You can run it on your machine, locally, or using any Jarvis server. Thanks for watching. If you found this lecture beneficial, please leave a like on the video, subscribe to the channel. If you have any questions whatsoever, kindly leave a comment down in the comment section below and I'll make sure I'll get to it as soon as possible. Also consider donating to my Patreon account any amount you wish, or through Bitcoin donations. I appreciate each and every one of your donations. It really helps a lot in progressing this channel. Also, NVIDIA is holding a GTC conference, that stands for GPU Technology Conference, and it is happening from the 12th till the 16th of April of 2021, where NVIDIA will be sharing the latest breakthroughs and news in AI, artificial intelligence, healthcare, game development, networking, and many, many more. And the best part about it is that it's free, so no registration fees are required. To learn more, I'm going to leave a link in the description section below, so you can go ahead and check this GTC conference. So thanks for watching, and I hope we'll see you there in GTC.